Hi there, today's lesson is on triangles, another lesson with a lot of vocabulary. That's kind of the thing with geometry. It's just a lot of things you have to remember in terms of what are these things called, okay? So first of all, a triangle is formed by three line segments that intersect only at their endpoints, meaning you have three line segments that come together and intersect at the endpoints. The point where they intersect here, these points here, are referred to as the vertex of the triangle. So you're going to have three vertices here with a triangle. Every triangle also has three angles. The sum of those angles is always going to be 180 degrees. So I take all the angles and add them up. We should always have 180 degrees. That's true for every single triangle. Now when you're looking at a triangle, there are always going to be two acute angles. Okay, has to be in order to get to 180. Then you look at the third angle in order to classify whether it is going to be called an acute, a right, or an obtuse triangle. An acute triangle is going to have as its third angle an angle less than 90 degrees. If its third angle is 90 degrees, then it's a right triangle. And if its third angle is more than 90 degrees, then it's going to be an obtuse triangle. So we have our acute, our right, and our obtuse ones. Okay, all based upon that third angle. Again, two of the angles will always be acute, and we'll look at some examples here. Another way of classifying triangles is by their sides. Scalene is going to mean that they have three different sides. Okay, all going to be different there. Isosceles means that two sides are equal to each other. And equilateral means that all sides are equal to each other. So again, we'll see some pictures here. If I have one that looks like this, and this, and this, right? Or, sorry, maybe go like that there, right? Now I have a scalene one because I have a side length, a different side length, and a third side length. Isosceles triangles often are going to have two side lengths that are the same like this, and the other one's not. And equilateral, it's going to be a perfect triangle where every side is going to be equal to each other. Okay, so my pictures aren't perfect there. That should be a little more, pointed, but you get the idea. So using this information is how we're going to classify triangles, and usually you work from the inside out when you're naming these things here. So first of all, find the value of x in the triangle right here. Well, the value is going to be equal to, because this whole thing is equal to 180, what I want to do is add those parts up and subtract that sum from 180. So I can do 66 plus 52, which is going to be 118, and I know the whole thing is 180, so when I subtract it from 180, I'll be left with the value of x. And in this case here, we'd have 62 degrees is the value of x. And you can do that for every triangle. Once you know a couple of the angle measurements, you can find the third, no problem, because it's always equal to 180 degrees. When it comes to classifying triangles, again, we want to look at that third side. This one says classify triangle by its angles and by its sides. Now, in terms of angles, we said there's always going to be the acute angles. Here's an acute one, here's an acute one. So we look at that third angle. This third angle is more than 90 degrees, which means it's going to be obtuse, right, on the outside. And then we look at the sides. We see we have two sides of the same. And when two sides are the same, that is the isosceles. So this is going to be an obtuse isosceles triangle based upon the third angle measurement and two sides that are equal to one another. Let's take a look at some other ones, because that's really what we're going to be doing today. Find the value of x, then classify. All right, so find the value of x. This should all equal 180. So I'm going to add those up together first. So we have 157 for that. I'm going to subtract it from 180. So I end up with 23 degrees is the missing measurement for x right there. Now in terms of classifying it, I have the two smaller acute angles, and I have this last third angle is also acute. So it's going to be an acute triangle. And in terms of its sides, I can just look at it here. Nothing seems to be equal as far as I can tell. We'd probably say it's an acute scalene triangle. although I don't have any information really about the sides. But in order for it to be isosceles, you'd have two angles of the same on the bottom, or if for it to be equilateral, all angles would be the same. So this is going to be a scalene triangle there. For the next one, we have 90, 43, and this missing part right there. So let's combine those together. So 90 and 43 is going to be equal to 133. So now we'll subtract that from 180. And 10 minus 3 is 7. 7 minus 3 is 4. So we have 47 degrees there. This triangle, the largest angle here is a right angle. So this is going to be a right triangle. And again, because these angle measurements are different, I don't know if any of these sides can actually be the same. We would probably call this a right scalene triangle. Alright, and the next one here, 40 and 45, which means I have 95 in total. Or sorry, 85 in total. Sorry about that. Now we're going to subtract that from 180. And then we're left with 95 degrees right there. Now that's greater than 90, so this is going to be an obtuse triangle, and again, probably scalene based upon what I see. So we have an acute one because it's 82, we have a right triangle because it's 90, and we have an obtuse one because it's 95 degrees. The last one, it wants us to do it by angles and sides, which means they'll give us information about the sides this time. So based upon angles, we have two acute. This is our largest acute one, but it's still less than 90, so this is going to be an acute triangle. We can see all the sides are different, so that's going to be acute scalene triangle there. In this case here, our largest angle is going to be the right angle there, so it's a right angle, and I notice that I have two sides of the same, so this is going to be a right isosceles triangle there. And our last one, our largest angle is here, it's obtuse. I don't have any parts that match for the sides, so it's an obtuse scalene triangle there. You're going to do the same thing with your lesson today. Just take your time, make sure you get your terms right. It's not too bad, but just kind of get it in your head of what these things are. All right, see you back here in a minute. All right, here we go. We're doing numbers 1 through 15 today. So first of all, we're going to find the value of x and then classify it as acute, right, or obtuse. So to find the value of x, I need to add those up first of all. So I know it's 165. Then I subtract it from 180 to come up with 15 degrees is the measurement for angle x. I have these are my smallest acute angles. This is my third angle. So this is going to be an acute triangle. Over here I have a 24 and 36, so I add those up. And we have 60. When I take 180 minus 60, I'm left with 120 degrees for this angle measurement there, 120 degrees. And that angle is my third angle. That makes this an obtuse triangle. The next one I have a 90 and a 49, so I'll add those up. And then I'm going to subtract it from 180 to find out the missing measurement there. And we have 41 degrees. So this is my largest angle, so we're going to classify this as a right triangle. Here I have 38, 38, so that's 38, 38 is 76. We subtract that from 180, and we have 7 minus 7 is 0, so we have 104. So we have 104 degrees over here. That's my largest angle, so it's going to be an obtuse triangle. This next one, 90 and 65, combine to give us 155. So now we subtract that from 180. And we have 10 minus 5 is 5, 7 minus 5 is 2, so we have 25 degrees right there. 65, 25 are my two acute angles, which means this is my my third angle. This is going to be a right triangle. Here, we'll add those up, 71 and 45. So we're going to be at 116. We'll subtract. And we have 64 degrees left for that one there. Those are my two smaller acute angles, leaving us that one as a third angle. It's still less than 90, so this is going to be an acute triangle. For number 7, I don't have a picture, but I can still find the missing angle. I have 57 and 51, which is 108. So I'm going to subtract that from 180, and we're left with 72 degrees for x. Now, of all the angles there, this is still less than 90, so this is going to be an acute triangle. Here, I can add those up. We have 148. I subtract it from 180. Oops. And we have 32 degrees left for x. So 32, 22, leaving me with that big angle there. This is going to be an obtuse triangle. Here, 90 and 50 is 140. We'll subtract that from 180 for a whole 40 degrees for x there. 40, 50 means this is my big angle, so this makes it a right triangle. Alright, the next one's here. We're going to classify each triangle, the given angle and side with measures. Okay, so I have a couple things here. I have all acute angles, so I know it's an acute triangle. I have two sides that are the same, so this is going to be an isosceles triangle. Here, the largest and third angle is there, so this is an obtuse, but I have two sides of the same, so this is also an isosceles triangle. Here, I have a 90-degree angle, which makes it a right triangle, and the side measurements, nothing tells me they're the same, so we're going to call it a scalene triangle there. The next one, I have all acute angles there, and I have 3 right sides, so this is going to be an equilateral. So it's an acute equilateral triangle. This next one, I have a right angle there, so it's a right triangle, and I have 2 equal sides, so it's a right isosceles triangle. And our last one, we have a large angle here, which makes this an obtuse triangle, and all 3 sides are different, so it's an obtuse scalene triangle. So just being familiar with those terms is what this is about, so make sure you're comfortable with them and know what they are. That's it for today. We'll see you next time.